Okay, welcome back everybody to the Python tutorial seminar series. Today, Anderson will be covering Xarray. This will be a continuation of the seminar 2 weeks ago. So this is Xarray part 2. This will also be recorded and published. Before we begin, as always, we need to review our code of conduct. By joining the Zoom call, you've agreed to participate in respectful communication only and adopt these values. Any inappropriate remarks will have you removed from the call. If you have help, the co-host will try to answer. If you need help, the co-host will try to answer your questions in the chat. And if that isn't sufficient, we will get you up to speed before the next tutorial, which it will be on Dask. Here are some useful resources for you. I will go ahead and post these in the chat in a second. So as always, Stack Overflow, the Xarray documentation, the content for the Xarray tutorials that Anderson is giving, as well as the YouTube recording from last session. So if you have not watched that, honestly, this session might not be the most helpful for you, but you should watch that and then come back and watch this recording. Okay, take it away, Anderson.
Okay, thank you, Julia. I assume you can hear me. Let me share my screen. Okay. Okay. All right. Okay. Give me a second. Okay, so welcome everyone. So as Julia mentioned, today's content is a continuation of what we did 2 weeks ago. So if you didn't attend the last session, I think it's perfectly fine for you to still follow along, but I think some of the things may not make sense until you watch the previous recording. Once again, so the content is in this GitHub repository, and if last time you followed along on your machine, you have to do a couple of things because I added some things to this repo ever since then. So let's see, there are 3 commands. So you will need to go to wherever you clone the repo. Give me a second. So, okay, in my case, somewhere. So once you get to the location of the repository where you have it locally, so if you made changes to the notebooks, so technically if you run the notebooks in the repo don't have the output, that means actually that Git will basically take those as changes. So you will have to basically run git add, basically add or stage everything that you currently have, and then do git stash. So basically that is going to stash things so that you can actually retrieve them later if you need to. And if you have things, then you should see a message there that tells you that git stash those things. And once you do this, just do a git pull to actually get the most recent changes. And you should at least get this message if everything is in a working state. Otherwise, if this is too confusing, then you can clone the repo in a different directory and then maybe come back to this later to figure out, well, what this actually means. But the idea is that we want to preserve those changes just in case you want to get them back later. And the way you would do that is you would, if at some point you need those changes, you just do git stash pop. So yeah, those are the 3 commands. So git add, git stash, and then git pull. If you're running this locally. However, if you're actually running this using Binder, then you don't need to do anything. Just go back to the repo and then click on the in the link. That should take a couple of minutes, hopefully not too long. But in the meantime, let me please go back here and at least try to review some of the things that we covered last time. Okay, wait a second. Okay. 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 So last time we went through some basics of Xarray. So we learned how to import Xarray. We learned about the call data structures, so data array and data set. And we now know how to open an NCAR file, look at the data set, and look at some of the components of a data set. We also know how to open other types of file formats as well. And then after that, we covered how to do the indexing and the selecting. So in this case, we're talking about positional indexing using ICEL, where we're basically indexing using integer positions in our index. And we talked about label-based indexing with cell, which actually uses the coordinate labels. And then we also talked about interpolation, but we haven't used it that much. And then lastly, we covered some aspects of visualizing Xarray datasets and data array using matplotlib and hvplot for interactive visualizations. Okay, this is taking some time, so I will just use my local version. But if you want to follow along, oh, I think this is actually gonna, yeah, this is coming online in a few seconds. I should have launched this way before the tutorial, but anyone who comes after, or who launches this after me, they should at least have a server very quickly. Okay, so today we're going to cover, so we have 3 notebooks. So we're going to cover computation as I promised. So we're going to look at some computation aspect of Xarray. Then we're going to look into how to mask data. And then we're going to switch gears and actually go through like an end-to-end example where we basically see how all these things that we've been learning for the last 2 hours since 2 weeks ago, how those things work in an actual workflow. Okay, this is taking too long. I will just, okay, so. Okay. All right. Okay. So we need to do 2 things. One, go back to that 00 download data notebook. There's more data that we need to download. Run that notebook. Again, that should take a few seconds. And at the end, you should have a couple files in the data directory. And once that is done, then actually let's head to the computation notebook. Okay. All right. Let me know if the font is good in, is big enough for people. Okay. So in this notebook, we're going to look at basically how to do basic arithmetic with data arrays and data sets, how to perform reductions or aggregations along 1 or multiple dimensions. And we're going to talk about Groupby, which is a very neat feature in Xarray for doing something called split, apply, and combine. We'll see what this means. And then we're going to look at couple other high-level computation routines. So let's go ahead and do some imports. So we're importing Xarray and then matplotlib because we are going to need it. We're importing NumPy, but I don't think we're actually using it. And now let's open this dataset. So this dataset here is the sea surface temperature from the CSM2 submission to CMIP6, and that spans these years. So as you can see, so we have our variable, which is sea surface temperature. Those are the dimensions, time, lat, and lon. And then if you go back to that variable, and if you look at the metadata, you'll see that there's a units, it's in degrees Celsius. So let's say we actually want to convert this into Kelvin. So the way you would do that is just, so the simplest way to do it is just take the variable and then just add whatever factor in this case, and Xarray will basically give you back a data array. So that's one thing. If you wanted to, we can square everything. In some cases, you can do more complex operations. So like in this case, if you wanted to apply the square root, you could just use the NumPy square root function and then pass in the variable. And Xarray will basically give you back a data array as well. So if there's something that you wanted to use from NumPy, usually if you just call that function on an Xarray object, you should basically get back a data array. Okay, so that's the basic arithmetic. So now let's talk about aggregations. So the way to think about aggregations is that, so these are usually things that you would want to use to kind of summarize the data in question. So like things like sum, mean, standard deviation, max. So the way you do that is, so we have our variable and want to compute the mean. If we're to call this, we get a single value. That is because Xarray is basically reducing all the dimensions. But we can actually tell it along which dimension we want to compute the mean. So in this case, I'm saying, let's compute the mean in time for all the locations. And if you look at this, what you get back is basically, it's a 2D data array, and then we can actually plot it. So that's what that looks like. So mean in time. So in this case, doing almost the same as what we're doing here, except that instead of computing the mean, we're just computing the minimum. Same thing here, where we're just computing the sum, but instead of just summing along one dimension, we can actually sum along a number of dimensions. In this case, we're computing the spatial sum, which should basically give us a 1D data array. We can compute the median. Like basically, there's a bunch of these. So the takeaway from this is, so you have some aggregation and you want to compute along a particular dimension. Xarray just makes that easy. So you just say data array dot the operation or the aggregation, and then here you pass in the list of dimensions that you want to compute that reduction along. So that's one aspect of reductions. So there's a bunch of other stuff that you can compute. Like for instance, you can count. So the total number of items. As we've seen, you can compute the mean, the median, the minimum, the maximum, standard deviation, the variance. You can compute the product. You can compute the sum. And then there's these other two, argmin and argmax, which will actually, instead of giving you back a value, would actually give you back an index. In this case, basically find the index of the minimum value. So that's some aggregations. There's a bunch of other stuff. You'd have to go through the documentation. But I hope that this at least kind of gives you an idea of what these aggregations are capable of. Okay, I hope I'm not moving too fast, because if I am, please let me know, then I'll slow down. Okay. Okay, so those are just simple aggregations. So now let's look at something different. So the simple aggregations, they will give you useful summary of your data set, but often you actually want to do those aggregations based on a condition. And what I mean by that is, let's say you want to compute climatologies. Like in this case, you want to group, let's say, all the Januaries, and you want to compute the mean on those. This is where the Groupby comes in. So the Groupby basically enables this concept of like split, apply, and then combine. So here I have this is my attempt at sketching what this actually looks like in action. But so the way you can think about it is, like in this case, let's assume that we have like a 3D input. So we have basically 2D panels, and then we have this third axis that I'm just going to group on. And so I have these labels. So you can think of these as your coordinate labels. Let's say, so I can tell Xarray, I want you to group by these labels. So in this case, we have 6 2D panels along this third dimension. So what Xarray is going to do is, when you call group by, it's going to create these 3 groups. So the A's are basically going to be in one group, the B's in another group, and the C's in another group. So, and then once you have that, you can then tell Xarray what you want to do on each group. So in this case, we can actually do an aggregation. So we can compute the mean. So we basically compute the mean for each group. And then at the end, Xarray will actually combine those things. So to you, most of these things are kind of hidden from you, in that basically you give it an input, you tell it what to group on, and then what you get back, and then you tell it the aggregation you want to compute on those groups. And then Xarray will actually give you back the combined results. So in this case, so we started with, so this axis you can see has 6 elements. And then at the end, we basically end up with 3 elements, because we group by these keys, and then we compute the mean, and that's what we get back. So we basically get a 3D, so 2D panels along, and then this third dimension. So that's what basically the Groupby does. So it's really useful for. So I don't know in other languages, but it really makes thinking about some computations very easy. So like if you wanted to compute like something like climatology, or in this case the seasonal cycle. So for instance, let's look at one of these locations. So if let's say, so we getting this longitude and latitude, and we're plotting the time series, you will see that there's a bit of a cycle. And let's say you wanted to remove this cycle from this data set. So the way you would do that is, again, using Groupby. So in this case, I'm saying, here's my data array. I want to group by on the month. So basically what this is going to do, it's going to basically group all the Januaries in one group, all the Februaries in one group. So basically all the Januaries for all the years that I have, and so on. So I should end up with 12 groups. So if I run that, you'll see that Xarray will actually tell me that I'm basically grouping over the month. And so these are my groups, or the labels of my groups, where 1 basically corresponds to January, 2 corresponds to February. So you see that I have this interesting notation where I'm saying ds, and then I'm accessing the time coordinate, and then I'm using this dt, which is basically something called an accessor, which in Python, the accessor basically allows you to enable some functionality that is, the functionality is there, but you have to basically be explicit that you want to use that functionality. So in this case, the dt allows me to have some additional functionality on the time coordinate. So for instance, I can do dt.year, and that will actually basically give me back the components. So for each time coordinate label, it will just give me the year that corresponds to that. I can do the month. There's a bunch of other stuff that you can do. So in this case, you'll see that you basically tell me what month that label is in. So January, so that's 1. December, that should be 12. So Xarray also kind of makes this easy. So because the time, so because we're grouping on the month, the month component of the time axis, we can actually do time.month, and Xarray will know what to do, which is basically the same as the other notation. I can do like time.year as well. I can do, let's say, time.season. And basically, so a bunch of these things are basically built in. But then more details are in the documentation. So once we group by, we can then apply some aggregations on that group. So in this case, I'm going to compute the mean. So my climatology. So what do you, so as you can see, what we get back is basically like a 3D data array. But now we no longer have the time coordinate. We actually have something that Xarray is calling month. And month is basically, so our month, so January through February. Now I can, for instance, like plot the climatology at that same point. You'll see what that looks like. Or I can plot, let's say, the zonal mean climatology. So I'm basically computing the mean along the longitude and then transposing that and plotting the field contours. So that's what the zonal mean climatology look like, right? I can do more complex stuff. So I can look at the difference between the January and the December climatologies. And the way they'll do that is just use cell month equals 1, then minus cell month equals 12, and then just do the plotting. And that's what the difference between the January and the December climatologies look like. Monthly climatologies, because you can compute seasonal, you can annual, like whatever frequency you're interested in. Okay, so if you're familiar with anomalies, so the way that you compute that is just compute the climatology and then remove the climatology from your original data. And that's what I'm doing here. So I'm grouping by time.month. So then I'm saving that in this variable. And then I take that and then I subtract the mean along the time dimension. So that should give me the monthly anomalies. So again, it's a 3D. We have time as usual. We can look at the anomaly at one of the locations. So this is the time series anomaly for this particular location. We can do more complex things. So for instance, let's say we wanted to compute the global anomaly in time. So in this case, I'm going to specify dm equals lat and lon. So this is what it's going to give me. But then because I'm reducing on latitude and longitude, this computation is not accurate because I'm not actually weighing these grid cells appropriately. So Xarray makes it easy to actually do weighted aggregations. So in this case, I have these. So I have another data set that actually has the weights for the grid cells. So this is the file that contains those weights. So let's open it. So we'll see that it's a 2D and it's basically filled with weights for our grid. So what I can do before actually computing the mean, I can tell Xarray that I want to use these weights, and Xarray will actually do the right thing. So anomaly dot weighted, and then I pass in the weights here, and then I do my aggregation. And we can actually look at what these look like, because if you plot this, you'll see that actually we're getting slightly different results. So the blue, those are your unweighted means, and then the orangish color, that's your weighted means. Okay, so yeah, okay, maybe that was too much, but so basically what we covered is how to use Groupby to do more complex computation. In this case, we just computed the anomalies, and we used the weighted method to actually do proper weighing of grid cells. You can use this for other purposes. Like for instance, like if you have, let's say, like a data set that has like things like time bounds, for instance, you could use that to actually weigh. So if you're let's say computing the mean across the time dimension, and you actually want it to weigh, let's say, months or days in months appropriately, then you could use that as well. Okay, so that's Groupby. So there's a bunch of other stuff. So there's Resample, which is basically like Groupby, but this is usually used for temporal upsampling and downsampling. So if you actually wanted to change the frequency of your time dimension, so the way you do that is you call the resample, and then in this case I'm telling Xarray the name of my time dimension, and then I'm telling it what frequency I want it to sample to. So in this case, AS corresponds to the start of the year. So this is annual frequency. So as you can see, we should end up with 15 groups, which corresponds to 15 years. I can do, well, we have monthly, which should basically give us the same. So 180, well, we can do even multiple frequencies. I can do, let's say, so 2M, meaning basically bi-monthly. Yeah. So yeah, you can do a bunch of things here. You can basically subsample, or you can upsample or downsample your time axis. So resample is really for the time dimensions. And then once you have that object, you can actually do aggregation on that. In this case, I'm just computing the mean. Basically, yeah. So resampling. Let me go back to what I had previously, which was AS. And then, so that's what so now I compute the mean. So you can do other type of aggregations here. You can do standard deviation, median, and all those other stuff. And then another one is if you wanted to compute things like moving window, so moving averages. So there's a rolling function or method. And again, the way that works is, so you call dot rolling and then specify the dimension. And then in this case, I'm telling it the size of my window, which is basically 5. So I have monthly data, so that means 5 months. And then you can pass in a bunch of other stuff here. I'm just telling it to, so center here says basically set the labels at the center of the window. And then I can compute the moving average. So the 5 months moving average. So this is how you do it in Xarray. Okay, we can actually look at some plots here where, so this is our moving average that we just computed right above, and then this is our original data set. You can see what that looks like. So that is rolling. And then lastly, okay, at least for this notebook, it's so coarsen. So this is mostly useful for downsampling data, basically regardless. So if let's say you wanted to downsample, let's say your grid, let's say you have, let's say, I don't know, you have, I don't know, a 1 degree grid, and you maybe want to coarsen that. This is the functional that you actually use. I don't think I have an example here in this notebook, but if you go to the documentation, you'll see what that looks like. So that's useful for downsampling other dimensions, such as lat and long. And if you wanted to do, so the resample, as we've seen, that is mostly for time dimension. So yeah, so there's a bunch of other stuff that, in the interest of time, I'm not going to cover, but if you go to these links, it should take you to the documentation pages with some examples. Okay. Julia, let me know if there's anything that needs to be addressed before I move to the next notebook. Otherwise, I'll assume that everything is good.
Everything seems to be good. There's no hanging questions in the chat.
Okay.
If you have a question, speak now.
Okay.
Okay.
Okay. So that was computations. So if you just want to go to the next notebook, just click on this. That should take you to this masking notebook. So masking. So in the second notebook, we covered indexing and subsetting. So masking in this case is useful for other purposes where, let's say, so if you remember with indexing and subselecting, you're basically getting a subset of the original data. But let's say in some cases, actually, you want to keep the original shape of your data, but then you just want to mask the regions that you're not interested in. So this is where masking is useful. And that is provided through a where method. There's also a function called, so there's a function where in Xarray as well. And that's what we're going to cover here. So basically, so you can use xr.where or where on the object, so method. And basically, you give it a condition, and then you tell it what you want to do on values that fulfill that conditions and the ones that don't fulfill the condition. And then Xr will basically do what it needs to do and then give you back something that has the same shape and pretty much everything as the original data, but then with some changes. So let's open the sea surface temperature data set again. And let's look at, okay, so this is, let's just take a sample here, just the first time slice. And so this is so this is the documentation. Okay, actually, if you haven't seen this notation before, if in a notebook, if you type question mark on, as in front of like a method or a function, it will basically give you the documentation or the doc string. And if you actually do 2 question marks, it will actually show you the actual code. But okay. Okay, so okay, this is what we're looking for. So you'll see that basically the first thing that we pass in is basically the condition, and then other, as stated here, basically, this is your field value for the data values or data points that don't fulfill this condition. So what you can pass in, so the condition can be a data array, it can be a data set, it can be even a function. And then we're going to cover some of these cases. So like I mentioned, so unlike iCell and cell that change the shape of the return results, so where will basically preserve the shape of the original data. We'll just mask those values that you're not interested in. So in this case, I'm saying, so sample.where, and then I'm actually masking using the actual values in my data set. I'm saying, I want you to mask locations with temperatures values greater than 0. And this may not make sense, but then if you actually plot it, so this is what it looks like. So this is our original data set. So on the left, we have the plot of our original data set, and on the right, we have a plot of our masked data set. And the regions that are shown on this plot, so the ones that are not white, are basically the regions that with temperatures less than 0. Yeah. So that's where, and we passed in one condition, but we can actually pass in multiple conditions. So the way you would do that, so you would need to basically wrap each condition in parentheses, and then use the bitwise AND or the bitwise OR to basically combine those conditions. And so in this case, for instance, like in this case, I'm interested in the region. No, actually, no. So a second. No. Okay. So in this case, I'm again using the actual values. But then this time I'm more interested in values that are basically between 25 and 30. So you see that we get back mostly regions around the equator, and then everything else is basically missing, as in Xarray just filled in missing values for those. We can, so far we've been using the actual values of the data array, but then we can also use where to actually, we can actually use where with coordinates. So in this case, I'm interested in this El Nino region, which is defined by, so it's between, so latitude, so -5 and 5, and then longitude, so 190 and 240. And that's how I'm basically selecting those. So I'm using, as you can see, I'm now using latitude values. And if I do that, you see that I basically get this region in the Pacific Ocean, I think. Yeah, that corresponds to the El Nino region. So that's how you would basically use where with multiple conditions. As the documentation says, if you don't provide a field value, Xarray will just put in a sentinel value, which is none, in NumPy that represents not a number. But then you can actually specify your own. So in this case, I'm just saying, just fill those with zeros instead. So again, passing the condition, and then the next thing is basically the field value. So yeah. So that is, here. Okay, so that is masking. And we'll see that, or we'll see how this is useful in the last notebook, which hopefully will at least kind of show you how all these things play together. So now on to the final notebook for today, which is, it's mostly just an example. So I don't have any instructions. I just kind of describe what we need to do. In this case, we're basically going to compute the Nino 3.4 index. And so the Nino region, again, it's defined in this bounding box. So -5 and 5 latitude and 170 and 120 longitude. I have a link. In this case, we're going to use the sea surface temperature from CSM2 submission for CMIP 6. And at the end of this notebook, basically, our goal is to produce like a plot that looks like this, with a few exceptions. Our period only spans, I think, 10 years. So we don't have any, at least we're not using any data prior to 2000, I think. But the plot should at least have some of these features where we basically label the Nino 3.4 index thresholds. Okay, so that's the region. Okay, so, and in this code, at least if you go to this page, it kind of describes how you would compute this. And if you've done this before, and you notice any discrepancies in my way of doing things, I apologize for that. I'm not a scientist, so some of the things may probably not be correct, but this is just my attempt at following these instructions. Okay, so we import some packages, and then we're going to open two datasets. So we open our sea surface temperature dataset, and then we open our weights, so our area cell. And then we're going to do something that I haven't actually covered, but it may actually become in handy in your own work. In this case, I have two datasets. I actually want to combine them in one single dataset or merge them. In this case, I'm using this merge function, and then I'm passing in those two as a list. Basically, what I get is basically like one dataset with, look at the variables. Now I have my actual variable, and then I have my weights or my area cell in one dataset. That's useful, especially if you don't want to keep referring to two different objects, and that's what I wanted to do. Okay, so the first thing we're going to do is let's look at the first time slice actually to make sure that things looks okay. And then also I'm doing more stuff here that I haven't covered before. In this case, I'm actually using CartoPy, which was covered, I don't remember, that was back in March. I think the tutorial was by Anissa, I think. But if you're not familiar with CartoPy, it's basically, it's more like an extension to Matplotlib, but then for cartography. So it will basically allow you to overlay maps on top of your matplotlib plots. So in this case, I'm plotting the first time slice, and then I'm setting a few things. So this may take some time when you run this, because it needs to download a couple of things like the coastlines, all of the stuff. But at the end, you should basically get something that looks like this. So this is our sea surface temperature for this particular time index or time label. And then you can play around with some of this stuff. But again, this is not a Cartopy tutorial, but I wanted to show you how you actually use it. So this is the global data set. But now the next task is, let's say now we actually want to discard everything except this region that we're interested in. So the NCAR 2.4 region. So we have two options. We can use cell and iCell because we know what the bounds are for those for that region, or we can use where. So you have a choice, but then well, I don't cover it here, but sometimes it's better to use cell and iCell, especially if you're using something like Dask. Well, I won't cover that, but the moral of the story is that the choice here may come with some advantages and disadvantages depending on whether you're using Dask or not. So in this case, I show you how you do this with cell. So I basically provide this slice object. I'm saying, so give me latitude from -5 up to 5, something with longitude values. And that will basically give me back this subset. So you see that now I'm only left with 10 longitude values, no, 10 latitude values and 50 longitude values. So basically now I don't care about the other regions. But then if you just wanted to do this by basically masking the data, this is how you do it. So again, use multiple conditions. And something else I didn't cover in that masking is that there's a way of telling where to actually drop the regions that you're not interested in. So instead of giving you the original shape with masked data, you can basically mask and then drop everything else that you're not interested in. And the way you do that is using this drop equals to true. One note is you probably want to be careful with this when you're using Dask because it complicates things. I won't go into the details about why, but yeah, that's something you should be aware of. Okay, so now let's just do like a quick plot to basically make sure that we selected the right region. So in this case, plotting the first time slice again, and then we'll see that I'm doing a couple of things. I'm setting the extent, which is like a way of like zooming in. So instead of like plotting the global map, I'm just zooming in this region. And that's my NCAR 3.4 region. You see that that's where I only have data. Everything else is basically just blank. Okay, so at least now we are confident that we have our data. So now let's actually now do the computation. So the first thing we're going to do is compute the climatologies and then remove the climatologies from the original data to basically compute the anomalies. And then we are going to compute basically, so we're going to also weigh, so we're going to compute mean anomalies, and then we're going to weigh them appropriately. So again, group by on month, and then remove the climatologies from the original data to compute the anomalies, and then compute the mean, compute the mean global anomalies, and then we are weighing them again appropriately by passing in our weights. Something else I didn't cover here is that when I did this here, the cell, because I'm selecting on, so using the data set, you see that everything else also, so even my weights or area cell are also subsetted as well. So basically, Xarray will know what to do for each one of these variables. according to whatever coordinates or dimensions you subselected. So that's why I can just pass in the weights, and I know for sure that these weights actually corresponds to those latitude and longitude values that I'm interested in. So we run that, and if you look at this, 3, 4. See that this is a 1D data array. So once we have that, then we compute this. So we smooth the anomalies. So by computing this moving average, so 5 months running or moving average. Again, how do we do it? We just use dot rolling, and then in this case, I'm specifying time, and then I'm saying, because this is monthly, so I want each window to have 5 months, and then compute the mean on that. It should be the same shape as the input. Again, still 1D. And we can actually look at what this looks like. We can look at the original anomalies that we computed and the 5 months running mean anomaly. You see that they're different. At least this is a sign that we're doing something the right way. And then once you have these 5 months running mean, you basically want to actually normalize them. And the way we do that is basically we want to compute the standard deviation over basically our original climatology period. So in this case, I'm just calling I'm computing the standard deviation on my original data set for that particular region. And this should basically be a single number, a single value. And then I'm basically taking my running mean, and then I'm dividing that by the standard deviation to do the normalization. And again, this should basically be the same shape as the input. And then here I do some stuff here that I didn't explain, but basically the idea is, remember how I say that our goal is to produce a plot that looks like this. So that's what that cell is actually doing. So I will try to explain exactly what's going on. So the El Nino 3.4 thresholds are basically -4 and 0.4. And this is what these two calls are doing. Basically, so I'm adding lines at the 0.4 and the -0.4, and then I'm filling in some data using, so in this case, you see that I'm using where to actually find the values that corresponds to these conditions. And then at the end, I basically plot my rolling mean. And what we get back is something that looks like this. So you see, so those are minus 0.4 and then 0.4 thresholds. And then we're basically filling in. So anything that is basically greater than 0.4, we label that as red, as you can see. And then everything that is less than -0.4, we label that as blue. And my understanding is that basically this corresponds to El Nino, and then the blue ones correspond to, I think, is it called La Nina, something like that. But as you can see, it's not exactly as this plot here, because this plot actually spanned almost 70 years. But then in our case, we only have 12 years, 12, almost, I think 14 or 15 years. But you get the idea. So yeah, so that's basically everything that we've covered so far. Like you open a data set, you select or you subset the data to just, in this case, we use cell, but you could have used where to just get to a particular region of interest. And then we computed climatologies and anomalies on that region. And then we plotted it. And then looks like we have a few minutes. One thing that I forgot to cover here is, let's say you don't want to do this computation again. So you already have your El Nino computed, and you want to save it to disk. So the way you do that is just call to NetCDF. Actually, I think because this is a data array, you actually want to turn this into a data set first. Let's give it a name. Actually, I think this should probably work. Yeah, this should work. So turn into a data set and then call to NetCDF. And then pass in like a path. In this case, I can just call it .nc. Then if I run that, I should then have an NetCDF file on disk. And you may use this NetCDF file for other stuff. So in this case, I'm just going to show you. I can call like ncdump on it, and that's my basically my saved El Nino 3.4. So basically, this is how you would save things to disk once you get done with whatever you want to do. And I realized that I didn't cover that, but it's as easy as just calling to NetCDF in this case. So yeah, so I think that's it for Xarray. So if you want to learn more about Xarray, or you actually want to see it in action, so there's a couple of resources. So there's the Project Pythia resource gallery. If you go to this link, you see like there's a bunch of stuff here, and you can come in and actually subselect things, and it'll basically gonna give you resources to some of these topics that we've covered. Let's say you want to cover, I don't know, CultPy, for instance. You can do that, and then it'll kind of point you to some useful resources. I think, how do I make this thing? Okay, give a second. Okay, I don't know. And then the other one is the Pancho gallery, which also has pointers to some other really neat use cases. So if you actually wanted to see, if this is your first time getting introduced to Xarray, these would really be good resources to check out to actually see how other people are using Xarray. Some of them may be advanced, well, because maybe they're covering things that we haven't covered yet, but at least after this tutorial, I think you should be confident enough to be able to look at a notebook and kind of figure out some of these topics that we covered. So those are the two main resources that I would recommend checking out. And with that, I will hand it back to Julia. And if you have questions, then we'll address those.
Thank you, Anderson. Great job. Yep. We just have one question in the chat right now that is about taking a binary file with data and what kinds of metadata you need to make it compatible with Xarray. My understanding is that you don't necessarily need any of the metadata, but Xarray will make use of it. So if you have a data without if you have a file without metadata, you can still make use of Xarray.
So yeah, so in some cases you may be working with data that is in what I'm going to call weird formats, like it's just like a binary file, and maybe you actually want to take advantage of it. So as a user, you may have to do some work, but there have been some recent work in Xarray that kind of makes it easy. Like for instance, if actually you wanted to, if let's say you're working with a huge amount of those kind of data sets, you could write what in Xarray we call like a backend, and there's some documentation on that. Let me see. Let's see if I can actually find the link to the documentation. And I think I'm hoping that this is like an example that show you how you would go. I don't think it has all the necessary information, but that's one way, basically where you write something that would actually be able to read the file directly and then maybe construct the metadata. under the hood. Another way is just read the file, and then you can actually construct the Xarray object by hand. We didn't cover that because I think it's a broad topic, because basically it depends on what you're trying to do. But you can construct like an Xarray data set from scratch. And I think the documentation is actually, let me see, I think it's, in a second. Where is it in the documentation? Forget. Okay, I think it's somewhere here. Yeah, if you go through the user guide, there should be some examples that kind of show you how you would go about creating this. Actually, this is the page. Looks like the data structures page. You'll see that you can actually create these from scratch, basically by hand, if that's what you're interested in.
I think moving forward, we're going to plan to have a series of sessions just dealing with specific data formats. So you have WARF, and we want to do everything that we've taught you using that data, open it, execute it, and as such. So if you guys have ideas of specific data files that you would like to see, feel free to email them to me, and we will make sure you know how to use your specific data. Or a smaller version of it if necessary, within all the tools that we've been teaching you.
All right. Yeah, so there's some aspects of Xarray that I didn't cover. So things like how Xarray works with Dask. If you're interested in that, that's, I think, topic to come. So I think maybe in the next 2 or 3 sessions, I think we should probably be able to cover that, because the next 2 sessions are going to be on Dask. Then after that, we can actually cover how Dask and Xarray work together. Any other questions?
Thank you, everyone. Please flood the chat with gratitude for Anderson. And if you have any questions before we end the call, we'll spot them.
Thank you, everyone. Okay, sounds like there's no additional questions, I guess.